All right. Well, I think that we have some people filtering in. So I just want to welcome everyone to the special impromptu stream. We've done a little promotion on IoT Village Twitter. So I want to introduce today a couple of current and former members of IoT Village staff. So first, just to let everyone know, my name is Sam. I've been with IoT Village for a while, and I wanted to make sure that we keep the content going. And with this, we're going to do an interview with a hacker, as this live stream is called. We have Shea Polansky over here. On my, which direction am I pointing? Is this the correct? No, that's Ted over here. So if I point over here, you're going to see Shea. Shea is over here.
Do a little like that Egyptian dance.
Yeah. So Shea over here, he's been part of our CTF engineering team. He's done quite a few tours with us, and now he's an alum, so he's moved on. He's working with a different group right now. And on my right, we also have Ted Harrington, who is one of the founding members of IoT Village and an executive partner at ISE, Independent Security Evaluators. So I'm going to pass it over to them now that I've done a thorough and delayed introduction to make sure everyone can filter in and join us for this awesome little live interview. So yeah, hey Ted, please take it away and let everyone know about what you're going to cover.
I was just kind of hoping we could watch you introduce us for the next hour, because I was thoroughly entertained by that. So
oh no, I mean that's my thing. I always like to vamp. I do the opening vamp as I see people filter into the space. You know, put your phones away. You know, get a cup of coffee. It's all good.
That's very, very good. Thank you, Sam.
All right, Shane, delete me from the image.
Awesome. Well, yeah, thank you everybody for spending some time here with us together this evening. As Sam mentioned, my name's Ted Harrington, and I've been involved with ISE with IoT Village since we kicked it off a few years ago. And what we're here to talk about today are essentially principles and concepts about how to actually think about securing software systems properly and identifying maybe some of the common misconceptions that exist out in the world and what those misconceptions should be replaced with. And so as we were thinking about doing this, and I should mention that a lot of where these ideas might come from, they're covered in a book that I actually just released earlier this week on Tuesday. And so the book came out. It's called Hackable: How to Do Application Security Right. And many of the stories in that book actually are directly stories from IoT companies, medical device companies, consumer grade router type companies, cars, you name it. And the book has gone really well this week, and we'll talk a little bit more about some of those things, but it actually wound up hitting #1 bestseller already, and we're only 3 days into it being a book out in the world. So as the book was getting ready to launch, what we were talking about was, well, how do we share some of these ideas with the IoT Village community? And how do we provide value and deliver content and just kind of keep the conversation going in between events? And so we said, well, maybe we should talk about some of the ideas in this book a little bit. And then that logically led to the outreach that I made to Shea, to ask Shea if he would be so good as to join me in a conversation. And Shea is one of the smarter ethical hackers that I've been privileged to work around, and someone that's been really important to me and to this book. Shea actually served as one of the beta readers, and so he read the crappy version that is not the version that you'll see in print. So Shea suffered through that, and Shea is very blunt, but he was very kind to me. And instead of saying it was trash, he was like, maybe this part could be different. And so Shea, thank you for carving some time out today. Thank you for all that you did for Hackable and, helping it ultimately hit that #1 bestseller. So thank you for being here. Maybe you want to talk a little bit about your background, and then we can dive into the content.
Sure. But first, I'd like to congratulate you. I hadn't actually picked up that it hit #1. So congratulations.
All right. Oh, yeah.
But anyway, so my background is in application security primarily, but also in network and systems and a couple of other kinds of security fields. My hobby would be embedded engineering, embedded security. So, I've got a pretty diverse background in that. But my formal background is just in general software development. So I bring a lot of like, here's how you actually build the systems to the table. And then that's how I break them.
Hell yeah. Yeah, when Shea told everyone it was time for him to move on to the next thing, of course we're excited for you, Shea, but we were sad to see him move on. But I'm really glad that we can reconnect here to talk about some of these ideas. So let's just dive in. Let's talk about some of these ideas, and maybe we start with the relationship between a company who builds a thing and the company who breaks the thing. And it's the question is less about business relationships, but it's about really relationships. So when you think about the way that a company, say they're building the next great IoT product or whatever, why should someone either work with an outside party like a security consulting company, or why should they build their own in-house capabilities, or why should they do both?
I mean, the answer to which of those you should do, I mean, you should do one of those, first of all, but the answer to which one you should do, it really is going to depend on the maturity of your organization, the political fields within, or factors within your organization, your timelines, and so on. Ideally, you would have both a mature internal security team, product security team specifically, not just a general security team that handles like, make sure your firewalls are up to date or whatever. And you would have external partners that validate the results provided by the internal security team. But a lot of organizations simply don't have either resources or time to develop the internal security team. So they have to rely purely on the external security team, or mostly on the external security team. And that's where a company, you'd go and you'd hire consultants, and the consultants would be your security partners who would go and try to break your stuff and then tell you how it's broken and help you fix it.
Yeah, that was one of definitely the core arguments that I was making here in the book about the relationship between the two, in that, a lot of companies, they think you should only be doing one or the other. It's like, we have the smartest people and we don't need outside help. I mean, I had plenty of executives say that to me, and it's like, well, I'm sure you have smart people. I'm not actually doubting that you have smart people, but there's certain things that an outside party brings, like independence and immediate, they can start immediately. There's no ramp up period in terms of like training and onboarding, the way you might have with a person in the team. But you really do need both. You shouldn't have outsource it entirely. You shouldn't only have people in-house. And how do you think that companies who do struggle with that sort of resource constraint, how have you seen people sort of think about that in terms of, it's hard to hire people, there's not enough of them, but then security consulting companies are expensive, or they're perceived to be expensive. What have you seen that works and doesn't work?
Well, I mean, the reality is that good security consulting is expensive. And the reason good security consulting is expensive is that hiring security people is expensive. And the reason hiring security people is expensive is because good security people are few and far in between. That's just the reality of it. And at some level, you can say, well, hiring security people, either external or internal, that's just a cost of doing business. Like treating it like a cost. Like, well, you got to do this. Like, you got to pay for electricity. You can't just not. But you also can leverage that and say, we have a world-class security team, whether that's external or internal or both. And you can leverage that as a sales pitch, as a differentiator, as a positive thing where you say, look, we put all this effort and energy into security. You, the customer, should trust us when you wouldn't necessarily trust someone else.
Mm-hmm. So let's talk about how then organizations should work together. And in particular, I want to talk about testing methodologies and black box versus white box. And, one of the things that people often are saying is like, oh, I want black box because I'm trying to emulate real world conditions. What should people be thinking about when they're saying, hey, I'm going to work with somebody to help me try to find my security vulnerabilities? How does that information sharing really play out in the real world? Is black box, in fact, a good way to find vulnerabilities, and why or why not?
So if you have a mature security program where you've already, you've done all of the things already, you've already hired external people, you have a mature internal security team, you have a mature detection team, you have, vulnerability research, so on and so forth. You've done all the things. At that point, it would be appropriate for you to say, okay, we're going to hire someone, or do it internally if you have the capability, to do a black box vulnerability, or sorry, adversary emulation. That's what this service is called, where the idea is that they try and emulate what a real, an APT type threat would try to do to break into your network or find your application or whatever. But if you haven't already checked all of those boxes, then doing a black box test is just leaving things on the table. And the reason for that is really simple, is that if I'm trying to, let's say you give me an IoT device and you said, find vulnerabilities in this IoT device. Well, I don't know what's running on it. I have to figure it out, right? I got to poke at it, do reconnaissance, try and reverse engineer it, and so on. And assuming you're hiring me as a consultant, you're paying me for my time to do this. So all those hours I spend reverse engineering it are hours that you paid me to discover stuff you could have just told me. It's like, oh, what software is this running on? Well, I can go find out. It'll take me some hours and you'll pay me X money for the hours, or you can tell me and then I know, and then it doesn't cost you anything. And that budget would go towards, vulnerability research, actually trying to find what's wrong with it.
So let's get the audience to put themselves in your shoes. Someone who actually is sort of on the very front edge of finding those vulnerabilities. So everything we talked about so far is sort of setting the table for success, right? You have to understand how different teams might work together, and then make sure that you're approaching it with the right information sharing. So let's talk about actually finding vulnerabilities. One of the things that you really helped me with, we went back and forth many times on, was one of the core ideas in the book is this triangle, which you recall that I drew out and had like the different steps to it. And the very top of the pinnacle, and I want to ask you about this particular thing because you really helped me think about the ideas sharper around this. So for everyone who's listening, I'll just give a quick recap. So the idea is that all testing, essentially, you need to understand the design of the system, who it's used for, how it's used, essentially understanding the threat model. Then you need to run your tools in order to run scanners and things like that to find the common known issues. And then as you move into the more advanced tactics, you're talking about abusing functionality, chaining exploits. And then the top of this pyramid, because you're imagining like a triangle, the very top of the pyramid, this was a question I went to Shea with as I'm sort of thinking about how to organize all these ideas. And the top is, you have to look for the unknown unknowns. These are the things that you don't even know if they exist. You can't really anticipate them. Things like novel versions of vulnerability classes or ODAs in the supply chain, stuff like that. And so, Shea, the question I had posed to you during the writing process was, is it a step looking for unknown unknowns? And what you said to me, which really stuck with me, is you said, well, that's not just a step. That's the pinnacle of security testing, is looking for those things you can't even anticipate. So can you maybe elaborate on that for the audience, of like what you meant by that, and
Sure.
sort of how this fits into the difference between, real quality effort that's very thorough to find issues versus more scan-based or automated type of approaches?
Yeah. So, I mean, if you basically, the pyramid model is one way of looking at it, but if you look at it instead as sort of like a time of, or amount of effort versus impact, I guess you could call it. So for instance, using a scanner, right? The scanner is typically going to pick up like known issues, like, oh, you're running, XYZ web server version 1, and versions before 1.5 have a known issue. Well, that'll pick it up, but it's also not going to, that's very low effort. And that known issue may be very severe, right? Because, maybe it's remote code execution or something. Then, oh, great, you had this easy win where you got whatever. But if, as the team of defenders, whether the defenders are an actual defense team, like you're attacking a corporate network, or a defense team as in the people who build the product, get better and better at their job and get better and better at security, your easy wins start disappearing and you have to start spending more effort. So instead of using a scanner, you start doing a little bit more manual effort where, you have to go in and try and poke at specific API endpoints or something like that, where you're just looking for common vulnerabilities, let's say XSS, but stuff that a scanner might not pick up because, let's say, it's, it requires, a complicated encoding process or a WAF bypass or something like that. And then as the defenders get better and better, you have to start looking at, okay, I'm going to start chaining exploits or abusing functionality where, this is intended to work this way. And a scanner wouldn't pick up that it's weird because the scanner doesn't, understand the human nature of the application. But you as a human can see it and maybe, oh, this bypasses this and this can be chained with this. And you get this long exploit chain that ends with something cool. And again, then your defenders will try and block that sort of thing. And all you're left with at the end, once everyone's exhausted all of the low hanging fruit and then the less low hanging fruit and so on, are these what would be called unknown unknowns. So like totally unknown classes of vulnerabilities, or ODAs in things people don't typically think about as being, security relevant, like, upstream vendor libraries or operating systems or something. And yeah, that'll get you into the system if you can find one. But, nobody can just pull, unknown class of vulnerabilities out of a hat. Or I guess if you can, you should probably, be working for the NSA or something. But the point is that, these things take a lot of effort to produce, and you're very likely not to find them. But when you do find them, they're extremely impactful because nobody's ever thought of them before. So to give an example of this, HTTP request smuggling was a relatively unknown, if not completely unknown, type of web application attack up until recently. But once it got out that this was a thing, people made tools to detect it or so on. People went on, everyone's finding them all over the place, because it turns out it's actually a very common misconfiguration, but nobody really thought about it until recently, even though once you know about it and can exploit it, it's this very high impact issue.
Yeah, I love the example of request smuggling. Actually, you helped me, sharpen how to talk about that in the book. There's some diagrams around it and everything. And of course, we keep it simple, not talking, it's not like a code level description of how to do the attack, but why stuff like that matters and how to think about it. And request smuggling is such an interesting technique because, yeah, it's like the very nature of the way something's built means that this type of attack is possible. And there's really there's now, like you said, there's ways to detect elements of it, but like there's no like button that you push that says, and find completely unknown attack techniques. You need to be thinking about them sort of differently. So you obviously, spend your career thinking differently, right? Having that sort of malicious viewpoint. And one of the things that you said to me at one point was, how did you phrase it? You said, my job is to ask the hard questions. How do you say it? No, it's to think the bad thoughts and ask the hard questions. And what you meant was like to think like an attacker and to identify and sort of undermine assumptions that maybe developers were made. Do you want to maybe elaborate and explain what you meant there?
Yeah, so you basically got it. So thinking the bad thoughts means I got to think like an attacker. So an attacker wants to break into your systems and steal your data and destroy your business or whatever they want to do. So I have to put myself in their shoes and think, okay, I want to do this. How would I accomplish this? And then the other part is asking hard questions. And the attackers will do that as part of their, they want to break in, so they're trying to figure out where you're assuming things. But directly, my job is to also just ask those questions, not to treat them as an attack. So that means, seeing, oh, you're making this assumption. Maybe it's not, I can't point to a security relevant right now reason why you shouldn't make this assumption, but I want to make sure you can really prove that this assumption will always hold true. So for example, things like no one will ever do XYZ. Well, what if they do? Or this system will always be available. Well, what if it isn't? And a lot of those tend to be overlaps between security and just good engineering practices. Because as an engineer, you want to say, well, I want my system to keep working even in adverse conditions. And those adverse conditions might not necessarily be somebody's attacking us. They could be, somebody cut a fiber line, there's a huge influx of users, something like that. And if you think about the security in terms of the CIA triad, confidentiality, integrity, and availability, well, confidentiality is pure security, really. But integrity and availability can both be impacted by things that aren't necessarily malicious in nature. So, for instance, if somebody cuts a fiber line, that impacts your availability, even though nobody intended to do that. So, it turns out that these security concepts overlap quite a bit with just good engineering practices. And one of the things that I pride myself on doing is trying to push people, whether it's through a security lens or just generally, towards those good engineering practices.
Yeah, man. So at the outcome of that type of effort, right, finding these types of vulnerabilities often means that the recipient of that information, the company who's building the thing, now has some sort of report that says, hey, here are the problems and you have to deal with them. And one of the challenges that I've seen over the years of doing this, and is actually one of the things that really motivated me to write the book, was that companies often struggle with that as a business problem as much as an engineering problem, which is we're already totally strapped. We have, we don't have any available resources. We've got looming deadlines. We're already deferring a lot of stuff. The CEO's, breathing down my neck. let's talk about the idea of prioritization and triage. How should a company be thinking about, they've got their long list of vulnerabilities. They have to prioritize in some way, or do they? So I guess that's really the question. What's the advice in terms of how to think about triage?
Well, of course you have to prioritize it. You know, just like everything else, there's limited resources and limited time, and you have to do the best you can with what you have. And a lot of companies find that they prefer to ship features instead of bug fixes, whether those are security or otherwise. And that is as much a business decision as an engineering decision, as you said. Now, typically you'll have a scale on security issues of informational, low, medium, high, critical. And obviously you'd say, well, as a security person, I want you to solve all of these things. But which ones you should solve, you know, tomorrow and which ones you can put off to maybe when you have time is going to depend on the severity of the issue, both in isolation and taken in context of your application. So your triage process then becomes hopefully working with the people who found the issues to understand the full impact and the full scope, and then decide, okay, you know, does this affect production systems on the internet? Does this only affect systems very few people have access to anyway? What's the impact? What's the severity? What kind of prerequisites are there for exploiting it? Like, do you need intimate knowledge of how the system works that very few people have? Or is it just like, you know, click a button and you win? You know, all of these questions, you should be working with your internal security people, your external, you know, whoever you have to understand the impact. And then from there, triage when it should be fixed.
Yeah. Yeah. And that's the big challenge, right? Is this sort of daunting workload. But then if I don't do anything, you know, it's like, am I going to do everything or do nothing? And a lot of people almost feel like those are their two options, like stop everything to do everything, or don't do anything with these. And that's, yeah, as you say, prioritizing based on the severity of the issues is exactly the way to do it. So let's talk about threat modeling. The threat model, you know, many companies, one of the things I've really observed over the years of doing this is that many companies, many individuals, they don't really know what a threat model is or how to apply one or why it matters. And the way that I always try to simplify the idea is that it's essentially helping you understand, you know, what do you want to protect? Who do you need to defend against? And where and how will you be attacked, essentially? And do you want to maybe elaborate on the idea of threat modeling and sort of how it fits into a company's approach to securing their system?
Sure. Threat modeling is basically the design level equivalent. So, you know, you're building a software project, you start with, first you have like an overarching goal, like we want to build an application that does whatever. And then from there you say, okay, here's how we're going to build it. We're going to use, you know, these cloud services, they're going to connect in these ways. It's going to have these, you know, these microservices or whatever it is. And the threat, and then, you know, then you actually implement those things and you have a test and fix cycle, and eventually it releases. So a threat model is the design equivalent for security. You're saying, okay, we have this design, you know, it's got these services, it protects this data. We've got, you know, here's our security goals, which are usually implicit. Most organizations I find don't have explicit security goals. They just want to be like, we don't want to get hacked, but that's fine. You can translate that very easily into, you know, we don't want people to gain unauthorized access to our servers or to get access to any data that they're not supposed to have. And you want to take that and say, okay, what threats are going to want to break into our system or attack our system or do whatever we don't want them to do? How are they going to want to do that? And what are they going to try to do? So for instance, a state-sponsored attacker might want to steal PII, or they might want to steal trade secrets. A cybercrime organization might want to ransomware your systems so that they can get money from you. So you have to elaborate on all that. And typically what you'll do is also model out data flow, like, you know, user data comes in here, it gets encrypted here, this service processes and so on. And then that guides your implementation of security features. Like, okay, well, how do we detect if user data is going where it's not supposed to go, for instance?
You know, of all the different ideas that that this book covers and that I, you know, constantly am preaching about, it's this idea of threat modeling that people wind up being most interested in for me to come teach workshops or give talks about. And it's because it's so foundational to security, yet many organizations kind of struggle to figure out exactly how to do it. And I mean, even today, maybe we should talk about attackers in particular. You know, even today, I find that there's sort of one group of people that thinks that like hackers it's one idea. Like there's just one group of bad guys out there and they're just this one thing. And then there's some groups that are like, okay, I understand there's these like different attacker groups like organized crime and nation states. And then there's just the insider threat. And they're like, that's one thing. And then there's the people that realize, oh no, even the insiders, like you got accidental insiders and disgruntled and whatever. So maybe let's dig into some of those. Let's start with the external attackers first. You know, when you think about whether it's casual hackers or hacktivists, organized crime, corporate espionage, nation states, how do you think that they sort of span on a spectrum from most problematic? I don't want to say least problematic, but like from problematic to like really problematic. How would you organize them?
I mean, on the one end of the spectrum, you'd have, state-sponsored attackers, obviously, because their key benefit, other than having lots of money available, is that they get to ignore things that would normally constrain people. Like, for instance, a state-sponsored attacker might have access to internet backbones or high levels of computing power or something like that. And let's say a similar organization that might not care about the law per se, like a cybercrime organization, they don't just get to snap their fingers and say, give me access to all of your data to let's say a domestic company. So that's why typically they're considered the most powerful attack groups. And then on the other side of the spectrum, you'll have people who are, casually experimenting. Let's say people who just figured out that, security is a thing that people do. I'm going to try it on random websites. And those typically people, they'll like run automated scripts or whatever, that, script kiddies as in the lingo. And, that they span, there's a whole spectrum between those of attackers with different motivations and different levels of access and power and privilege. And in terms of what you want to target, that really depends on what, organizational goals and business goals and resources and so on. But typically, I would say, designing your systems only to need to defend against the casual script kiddies is probably not the correct answer. Although, as with nearly anything when you talk about security engineering, just like any other kind of engineering, it's very much a function of business goals, where, yes, you could say, oh, I want to build a system that will keep out everybody forever, period. And, you could spend an infinite amount of money doing that, and maybe it'll work, maybe it won't. I mean, people, even well-funded organizations with lots of cyber or security talent, still do get hacked. I mean, there was FireEye, who you'd think would be, they're a security company, they would have very good security, just announced that they got hacked and all their tools were looted by an APT group. So, it becomes a business decision on the trade-offs.
Yeah, totally. I remember I've told you this story before, but I remember being at a healthcare technology conference, and the keynote speaker of this particular conference was the CTO of this major healthcare system. And he's up there and he's talking about their threat model. And he's saying, oh yeah, we don't even try to defend against nation states. And I remember when he said that, everyone in the room was like, it was like you could hear a pin drop. It's like, are you allowed to think that? But the point he was making, which I don't know if I necessarily agree with the decision, but I respect that he made a decision based on appropriate criteria. And his decision was, well, our resources are going to be best utilized in a particular way. And the amount of resources we have, we wouldn't even make a dent against that type of attacker. So we're going to focus on trying to defend against other types of attackers. And I mean, how do you feel about that? I guess I should ask.
I mean, as a security person, it's very difficult for me to recommend not trying to defend things.
Yeah.
But I can't say he's necessarily wrong, on its face, because there is typically a very big gap between what's available to a nation state and what's available to anyone else. Even, there are cybercrime groups that do people do class as APTs and that do have, extensive resources available, both in terms of expertise and money and so on. But even those would typically be considered to be, there'd be a gap between even those extremely powerful cybercrime groups and actual nation state actors. So it's not wrong on its face to say that. And I'm sure that they went to I hope that they went to quite a bit of, effort trying to quantify how much more resources they would need to effectively defend against a nation state. But it is a little bit troubling to hear that, especially because, I mean, from ISC's old research, we've seen ways to kill people using hacked medical devices, and there's quite a bit of people and medical devices in hospitals. So
yeah, man, that was what was harrowing for us, right? I think we had just published the research before that had happened, and I'm like holding the report of here's how people could hurt patients, and here's the dude being like, oh yeah, we just don't. Anyway, it's a difficult position he's in. I mean, especially in healthcare, where just
on the other
bureaucracy gets in the way.
It is part of threat modeling to consider, okay, not just who could be attacking you, but why they would want to do that, right? And part of the threat modeling judgment may be that a nation state attack, we don't have anything of interest to a nation state, right? Because, if it's a hospital, there might be a high profile patient the nation state might want information on or potentially to do harm to. But other than that, maybe they say, well, we don't have proprietary information, which is a hospital, right? We just treat people. We don't have, up and coming engineering blueprints that they might want to steal. We don't have lots of money. We don't have, trade secrets they care about. Well, there's nothing for them to care about, so they probably won't attack us. And again, that is a threat modeling decision that you can make, and it may or may not be true, but at least it should be something documented and something consciously decided rather than something just unconsciously understood.
Yeah. I had this other conversation I thought that was really, really interesting on the element of thinking about the assets part, like what are you trying to protect? Where I was talking to this CTO of a company that basically what their software does is it handles ticketing for events and festivals and stuff like that. And this CTO is talking about how at that company, they don't have anything valuable to protect. And this individual was talking about, oh, we have email addresses, but that's about it. We don't do the payment processing or anything like that. That's third party, whatever. And I thought that was really interesting because then as I started, because I didn't actually think that was true. And so I started asking a bunch of questions and, come to find out, think of all the different ways you'd want to attack a system that, has to do with a festival, right? You might want to make one ticket could be used 100 times, or you make none of the tickets work, or, someone might want to, an attacker might want to bring a bunch of their friends in. Maybe they want to make the ticket, they want to be able to sell counterfeit tickets multiple times. And it was really interesting having that conversation that when I sort of started laying out, well, what about this? What about this? What about this? This person was saying, oh, I guess I do need to protect that too. And that's sort of the power of threat modeling. They hadn't thought about it. They thought about it more in just terms of like, what data do we have that someone would want, as opposed to what outcome could an attacker arrive at? And what do you think about that?
A good way to think about that is to ask, is anytime if somebody wants to do something and you would tell them they're not allowed to do that, that's part of your threat modeling process. That's something you have to put down as part of your threat modeling. You assign it to actors and so on, to threat actors and so on. But once you have it in your threat modeling, then you have to, that gets incorporated into your engineering process. So, in the ticketing example, right? Yes, you'd say, well, somebody, if you want to read data off our servers, well, you can't do that. Sorry. But you would also be, ticketing is an access control system, right? You'd say, well, if you buy a ticket, you get into the venue or whatever. If you don't buy a ticket, then you don't. You are going to assign people to physically stand there and prevent people from getting in who don't have tickets. Well, you are tying that physical system to a digital system, a computer, your application. Your application needs to also prevent people who don't have tickets from getting into the venue. So anytime you have, you can think of it just like a physical barrier, wherever, if you wanted to prevent people who weren't authorized to get into a building, you would hire a security guard. And the security guard would stand at the entrance and prevent people who weren't authorized from getting in. And you do the same threat modeling for applications, where you'd say, well, okay, I'm going to document that I want to keep people who don't have tickets from getting into my venues. I'm going to document that tickets should only be used once. I'm going to document that if you don't buy a ticket, you shouldn't get a ticket. And that's part of your threat modeling process.
Totally. So as we wrap up, maybe we can leave everybody with sort of one last story. Maybe you could talk about the badge scanner research that you did at sort of the end of your time here at ISE. That was just such a cool thing that you found, and you just sort of like found it on like on the fly almost. So maybe do you want to talk people through that, and maybe your thought process of how you approached it and why you did what you did?
Sure. I'm going to be vague because it hasn't been disclosed yet.
Sure.
Disclosed. But we were at an event, and the event used an electronic badging system. And so, you had this, people, if you wanted to get in, you would have a badge, like, a little plastic badge you'd wear. And the people at the security guards at the door would scan your badge. And if it, said, it would say, welcome, whatever your name is, and then they'll let you in. And if you didn't have the right badge, let's say if you paid extra, you got access to certain events or something, then it would say, access denied. And then the security people would be in charge of preventing that. So I saw this and I was just like, so I was bored, we were running a booth, and there was a lull between, people coming in. So I started playing with the badge system on my phone, and it turns out it was NFC. So my, most phones nowadays have NFC, so they can read the badges, at least to some degree. And, so I started looking at it, and it was like, oh, this is an NFC badge. And it turned out that we had actually rented one of the badge scanners because they were also used for surveying. So, you could scan people's badges, and then the conference would give you their email addresses so you could send them spam later. And, so I take this device that is used for scanning, and it's basically a phone that they've modified with different software. So I examine the phone, and it turns out that it's an older Android phone that you can very easily root and get access to. So I root it to gain access to the data on it. And we found that the badges were being extremely poorly encrypted using this homegrown encryption system that was awful. So awful, in fact, that now that I knew how it worked, I could even determine at a future conference, assuming they rotated the key, what the badge, what the new encryption key was, just from reading my own badge, because I knew what was on my own badge. And that's an example of how your security system, your threat modeling is really important, because they had failed to consider that someone who had one of these badge scanners, because they costed a bunch of money to rent as a vendor, might want to gain further privileges than they were already allowed to have. They'd assume that, oh, the vendor won't do that because, they're just a vendor. They're going to pay us, and they're going to be nice. And essentially what I was asking is, what if the vendor isn't nice? And the answer is, then they get a lot more than they're supposed to. I could read badges, I could forge badges. So I could, re-encode my badge so it said that my name was Donald Trump, and go around, and people would have to say, yes, welcome, Mr. Trump. And I could also submit fake badges. So, I could pretend that I had scanned everyone's badge so that I could get all their email addresses, even though I wasn't supposed to have them. And
sorry, keep going. Didn't mean to speak over you.
No, I was going to say, and the sort of culmination of it is, this was, of course, reported to the vendor, and they're still working on fixes. So I'm vague on specifics. But the lesson is that, number one, they obviously should have hired someone to do security analysis on this system, because this was very basic. I was doing it in my hotel room while I was bored and waiting for dinner. And number two is that it was a threat modeling failure more than anything else, because the biggest failure in their security was simply asking the question, what if somebody attacked this not on the basis of it being a badging system, where somebody's going to try and trick their way into the conference by sweet talking the security guard, or like dodging the checks or whatever. What if they had treated it like a computer system, where they're like, okay, well, there's some kind of cryptography going on, there's some kind of systems that are more trusted than others, how can I exploit this stuff?
Dude, it's such a rad story. I mean, I lived it like in real time as you were going through all those different steps, and still hearing you tell it, I'm like, and then what happened? So that's just awesome. Thanks for sharing that. I think that there's a lot of lessons that people can take out of that, about as they're building their own, their own IoT systems, about how to think differently, how to have that sort of adversarial mindset. So Shea, you've been the man. Thanks for joining. And yeah. So I guess with that, we will kick it back over to Sam to wrap us up. But anybody who wants to understand more about these ideas, feel free to reach out to the team at IoT Village, or if you yourself have done research and you want to participate in the community, come submit to give a talk. Pretty much everything Shea and I talked about today is covered in my book. It's called Hackable: How to Do Application Security Right. You can get it at Amazon or hackablebook.com. And also all my contact info is there too, if you ever needed to talk to me. So I guess that's it. Sam?
Hello, this is Sam, the voice from above. Thank you so much. This was really fun. I think this might be the start of maybe a more regular thing we do with the stream. We've been building up a platform all this year now that we went online. not being able to go to real conferences. So we might be reaching out to other people in the community. Ted or one of the other people might be doing more interviews. I think this is a really good use of our platform. Our Discord, you can always find us at iotvillage.org, and you can connect to us with our Discord. And from there, we have already a community of 1,000 people. And it would be really cool to maybe bring on some previous speakers or some upcoming speakers. We have nearly 20 events lined up for 2021. So any more collaboration we can do, or ways we can provide the community more value with the different platforms we have, would be really fun for us. So it's a collaborative thing. Don't think that we run everything. It's really like, if you guys demand something, if you want to see more stuff, we'll make it happen for you all. Ted and Shea, it was awesome hearing your stories and hear you talk about the different lessons you've learned. So yeah, I don't know how to end this. I don't want to.
You could say goodbye.
I miss Shea.
I miss you too, Sam.
All right, cool. Well, let's see. Shane, he's working the machines, the machine gods. He can control this. So Shane, if you wanted to, cancel this meeting at any time and cancel this live stream, just go for it.